Welcome to aminacademy.com. In modern physics, let us discuss about Michelson-Morley experiment. All waves that were known to 19th century scientists required a medium in order to propagate. Surface waves moving across the ocean obviously required the water. Similarly, wave move along a plucked guitar string across the surface of a struck drumhead through earth after an earthquake, and indeed in all materials acted upon by suitable forces. The speed of the waves depends on the properties of the medium and is derived relative to the medium. Michelson realized that although the effect of Earth's motion on the result of any out and back speed of light measurement, such as shown in figure, would be too small to measure directly, it should be possible to measure, that is v squared by c squared, by a difference measurements using the interference property of the light waves as a sensitive clock. The apparatus that is designed to make the measurement is called a Michelson interferometer. The purpose of the Michelson-Morley experiment was to measure the speed of light relative to the interferometer, that is relative to Earth, thereby detecting Earth's motion through the ether and thus verifying the latter's existence. To illustrate how the interferometer works and the reasoning behind the experiment, let us first describe an analogous situation set in more familiar surroundings. Here, Michelson-Morley experiment. An attempt to detect the velocity of Earth with respect to the hypothetical luminiferous ether, a medium in space proposed to carry light waves. That means ether is required to propagate light waves. That means this is called luminous ether. First, that medium is called ether. That earliest scientist proposed there must be an ether. A medium in space proposed to carry light waves. First performed in Germany in 1880 to 81 by the physicist A. Michelson. The test was later refined in 1887 by Michelson and Edward Morley in the United States. The procedure depends on a Michelson interferometer, a sensitive optical device that compares the optical path lengths for light moving in two mutually perpendicular directions. Here, this schematic diagram for the interferometer. Here, first this longitudinal and transverse waves expected to arrive in the phase when v equal to 0. Here is the right source, and longitudinal and transverse waves expected to be differentially recorded when v equal to greater than 0. Here, this is the setup experiment schematic diagram. The procedure depended on Michelson interferometer, a sensitive optical device that compares the optical path lengths for light moving in two mutually perpendicular directions. That means this procedure is a sensitive optical device that compares the optical path length for light moving in two mutually perpendicular directions. Michelson reasoned that if the speed of light were constant with respect to the proposed ether through which Earth was moving, that motion could be detected by comparing the speed of the light in the direction of Earth's motion and the speed of the light at right angles to the Earth's motion. That means the comparison of speed of the Earth was moving. That motion could be detected by comparing the speed of the light in the direction of the Earth's motion and the speed of the light at right angles to the Earth's motion. That is, in two directions is detected. No difference was found. This null result seriously discredited the ether theories and ultimately led to the proposal by Albert Einstein in 1905. That means ether theory is after that was not used because the Einstein proposed that there is no change in speed in light in any medium. That speed of the light is universal constant, he proposed. Here, look at this. Here, this is a schematic diagram for interferometer. Here, light source is here. This light directly passes through, and it is detected when longitudinal and transverse waves expected to arrive in phase when v equals 0. This side is longitudinal and transverse waves expected to be differentially retarded when v equals greater than 0. Here t time taken is 2L square root of c square minus v square, where c is the velocity of light and v is the velocity of the source's medium. Here now we'll continue on some calculations. Here let T1 is A to B, that is from here to here to B is L1 by C plus V plus L1 by C minus V. Here addition of L1 by C plus V plus L1 by C minus V is the T1, which LCM is C plus V, C minus V, C square minus V square. Here by cross multiplying and simplifying you get 2CL1, which will get 2L1 by C1 take out 1 by 1 minus V square by C square. That means we are taking C1 out, and that is here 1 minus V square by C square comes. Same T2, that is where we have used the binomial expression to simplify this. The time taken T2 is another set from here to here, which gives 2L2 over square root of C square minus V square, which gives 2L2 over C into 1 over square root of 1 minus V square by C square. That means by simplification it gives like. Now change in time, that is delta T equal to T2 minus T1 equal 2 over C take out and L2 over square root of 1 minus V square by C square minus L1 by square root of 1 minus V square by C square. Now here delta T days equal to T2 days minus T1 days, which is equal 2 over C into L2 over 1 minus V square by C square minus L1 over 1 minus V square by C square. Here then we'll get delta T square minus delta T. This delta T square is T days is this expression, and delta T is this expression. Subtracting both, we'll get after simplification we'll get 2 over C into L1 plus L2 over square root of 1 minus V square by C square minus L1 plus L2 over square root of 1 minus V square by C square. Now delta T days minus delta T is equal to 2 over C. Take out L1 plus L2 factor out, and this is LCM is this, and go up is 1 minus V square over C square power minus half. After using binomial expression, we will get this. Sometimes we will get this. Here, first expression is this one, 1 minus V square over C square whole power minus half. Expression is this, and other higher terms are neglected. Then here also, and higher terms are neglected. Then we will get, generally this expression is V square into L1 plus L2 over C square. This is this experiment's result in, that is, we can call this as a formula of Michelson expression. Now we'll discuss the nature of light. As a result of Michelson force in 1879, the speed of light was known to be hardly about 1,86 and 350 miles per second. It is approximately equal to 3 lakhs kilometer per second with a likely error of around 30 miles per second. This measurement made by timing a flash of light traveling between mirrors in Annapolis agreed with less direct measurements based on astronomical observations. This is a precise measurement conducted by the scientist, physicist Michelson, based on astronomical observations. Still, this did not really clarify the nature of light. Still, something we need extra information. 200 years earlier, Newton had suggested that light consists of tiny particles generated in a hot object which spray out at very high speed, bounce off other objects, and are detected by our eyes. Newton's arch enemy Robert Hooke, on the other hand, thought that light must be a kind of wave motion like sound. To appreciate his point of view, let us briefly review the nature of sound later. So far we have done something about some ideas about Morse, Michelson and Morley experiments and its simple derivation, and about the nature of light proposed by Newton as well Thomas Hooke. So far we have done. Please subscribe our YouTube channel.